For number 27, we have a system with no solutions. We want the value of r. First thought often is to try to use Desmos on this one. And, maybe it works okay in this case. It's not something I can sign off on because there could be scenarios where you're just not going to get lucky with your slider, basically. But we're going to go ahead and put this in. And we're going to include r for the second one. And we're going to have to add a slider. And so at this point, let's kind of expand the range here. So negative 100 to 100. We need this system to have no solutions. What does it mean if there's no solutions? It means they never intersect. When does that happen? It happens when the lines are parallel. So I need to fiddle around with this slider until I get something that looks parallel. And that also, to me, is a concern. We have to eyeball it, which, as long as we're careful, we're probably going to be okay. My only concern here, like if we just click around a little bit, this looks pretty close. Okay, somewhere in between them, like that, negative 28. And if we just kind of look far and wide, it doesn't look like it's getting any closer. It does look parallel. So, okay, fine. We can say r is negative 28. But, I wouldn't put it past them to make the answer for a question like this end up being something like negative 71 thirds. And then what? Are you going to get that in the slider? I wouldn't want to take that chance. Again, if you're trying to go for a top score, we can't let chance play a role here. We need to be able to handle anything that's thrown at us with consistency and security. We can't just be like, well, I'll use a slider and hope it all works out well for me. It probably will, but personally, that's not very comforting to me. So what's the way we can solve this directly? First thing I want to do is get it in kind of the standard form you would see for your systems where it's like ax plus by equals c. So let's combine like terms. Let's get all the variables to the left side. Let's get the constant term to the right side, and let's regroup from that point. So top equation, I'm just going to subtract 48y from both sides. So I'm going to get 48x minus, that's going to be 112y equals 24. Bottom equation, I'm just going to add 12x to both sides. It's 12x plus ry equals 1/8. So here's the deal. When you have either no solutions or infinite solutions, what is true in both cases is that the ratio of these coefficients must be equal. So when I find the ratio of 48 to 12 and the ratio of negative 112 to r, I can set them equal. In other words, set up a proportion. And this lets me solve for r directly. I don't have to fiddle with the slider or do any kind of nonsense. So 48 over 12 is equal to negative 112 over r. And we just go ahead and cross multiply and solve for r, and we're good. So 48r equals negative 1,344. So now we'll divide by 48. Oops. So divide by 48. Oops. Start over. So 1344 divided by 48, we get 28, or negative 28. And that should look familiar. Now, one thing you could do as a kind of a half measure with Desmos is once you do it by hand, and we get an answer of negative 28 or 71 thirds, whatever crazy answer we get, we can then use Desmos to check, right? That's one way to use Desmos is to check, like, okay, now that I've gotten negative 28, does it work? And if I plug in negative 28 for r here, so let's just delete this slider. Let's just put this as negative 28. And I get something that looks pretty good like this, 99.999% of the time, you're right. So you can use Desmos to get an answer directly, but I like using it very often to check my work, to do it by hand, to do it the secure way that I know is going to work every time, and then use Desmos to check. As a side note, you may also be asking, well, what would happen here if this said infinite solutions? How would that change our approach? For this particular problem, it wouldn't. We would still set 48 over 12 equal to negative 112 over r. The difference between no solutions and infinite solutions has to do with these values here. If we went ahead, let's go ahead and set up our proportion here. So 48 over 12 equals negative 112 over 28, or over negative 128. We just found that. We set these two pairs equal to the ratio of these constant terms. And whether or not this is true determines whether we're in no solutions or infinite solutions. Notice in this case, the ratio here is 4 to 1, right? This is 4, this is 4. But when I do 24 divided by 1/8, I get 192. And so these are not equal. And when these two are equal, but not to this one, that is the no solutions case. If, on the other hand, this were 6, what would happen? Well, we would get, again, 4 equals 24 over 6, which is also 4. This should be, in that case, the infinite solution situation, because basically what you have is the same equation. One's just a multiple of the other, but they're the same, and so they're going to overlap each other. And so just to check, let's put this into Desmos and see if indeed this would be infinite. So we're going to do 48x minus 112y equals 24, and then 12x plus or minus 28y, and then we're going to make that change that I did, call it 6. And yeah, look, let me turn that color to different color here, blue. So when I toggle the blue line, it's the same line. So this shows us this would be infinite. If you're curious, how did I get 6 quickly? It's just knowing that the ratio's got to be 4 to 1. So I had to think, what divided into 24 gives me 4? And that would be 6. So that's the difference between infinite and no solutions. Both of them, the ratio between these two should be the same. But if these three are not all the same, if these first two equal each other but not this one, that's no solutions. And this is what happened restoring our original problem. This is what happened in our case. This was no solutions. But if they're all equal, then it's infinite solutions. So that's the only difference. That's why I like setting out those proportions. Direct, you don't have to fiddle with the slider. And we get our answer, which you can then check with Desmos. So this is negative 28.